Okay, welcome back. This video is just going to be about basic exponential functions, and in particular, just how to sketch a basic exponential function and the overall shape that we observe when we sketch a basic exponential function. So what I've got written here is y equals a to the power of x. This is the most basic exponential function that you can have, where x is the variable and the variable is the power this time, and of course y is the other variable here. But one thing to point out is that the base number a cannot be 1, because if we have a base number of 1, that ends up, and say we have x is equal to 2, we'll have 1 squared, which just gives us 1 again. If we have x equal to 3, we have 1 times 1 times 1, which just leaves us with an answer of 1 again. So having a base number of 1 is not going to give us much of a graph. So we'll look at other examples with different base numbers. So the first one down here is y equals 2 to the power of x. If we just wanted to sort of look at the numbers we get as a solution, if we let different x values to be different numbers. For example, if I say x is equal to 1, that's going to give me a solution of 2. Another example, if I let x equal to 2, that'll be 2 to the power of 2, and 2 squared is equal to 4. And then we carry on like this, and we'll be able to see different solutions here. So the first one, if x is equal to 0, we've got 2 to the power of 0. Anything to the power of 0 is equal to 1. And then the next number is 2, which we've already established. If x is equal to 2, our solution is 4. If x is equal to 3, our solution will be 8. You can check yourself. And if x is equal to 4, our solution will be 16. So the shape or the trend that is sort of coming out of this is that our solutions 1, 2, 4, 8, 16 are growing quite rapidly compared with the x values, which is just going up by 1 every time. 0, 1, 2, 3, 4. And the shape of the graph from this looks exactly like this. So as the x values increase by increments of 1, the y values are increasing by greater and greater amounts. So just look at the steepness here. Okay, that steepness is not so much, but the next jump, it's much more steep. The next jump, it's more steep, and we can see here for our for an x value of 5, that increase in y is much greater than what had followed before. And this trend will continue if we keep increasing the values of x. So this is characteristic shape of an exponential function. So we should expect to see this when we graph or sketch an exponential function. So the first problem here, and again, pause the video, try and solve it out, try and solve it yourself, see if you get the same answer as this. But I'll start now. So y is equal to 3 to the power of x. If we're trying to solve or sketch a graph, we always want to try and say, for example, try and find the x-intercepts and the y-intercepts first. That's always a good starting point. So I think we should try and do this and see what happens. Let's say we will let x equal 0 to try and find the y-intercept. So y is equal to 3 to the power of 0, and anything to the power of 0 is equal to 1. So our first coordinate that we can plot is 0, 1. Let's see what happens if we let y equal 0 and solve for x. So this will give us the x-intercept if there is an x-intercept. So I'll let y equals 0 equals 3 to the power of x. To get this x out, we need to remember our logarithmic rearrangements so we can actually find that solution for x. So the base number is 3. So I'll write log to the base of 3. The logarithm always tells us, or the logarithm is equal to the index. The index is x. So that will go there. We only have a 0 here. And if you were to type this into your calculator or try and solve this, it turns out that there is no solution for this. You can't take the log of 0 or any negative number for that matter. So no solution there. So we don't get very far with that. So let's, for the sake of it, just choose a different x value, just so we have another point on the graph that we can connect between. I'll choose an x value of 2 because that's a nice simple number. Y is equal to 3 to the power of 2. So 3 to the power of 2, 3 squared is 9. So another coordinate we can plot is x is equal to 2 and y is equal to 9. 2 coordinates there. So let's go ahead and actually plot this. So 0, 1, let's say 1 is about there and 0 is here for x. And 2, let's say 2 is about here. And 9, let's say is about there. So we've got one solution here and another, or one coordinate there and another coordinate there. We saw the shape of the graph before, that it has that rapidly increasing type shape. So let's connect these points, not by a straight line. Don't put a straight line. That's not the shape of an exponential function. The shape of an exponential function will be something like that, that sort of shape. And at the moment, just for sketching a basic exponential function, this is fine. There are a few other properties to talk about, but at the moment, we just want to get the solutions to the function and the overall shape. Slightly different example. Y is equal to 2 to the power of negative x. We'll start in exactly the same way by trying to solve for an x-intercept and trying to solve for a y-intercept and see what happens. So let's let x equal 0 and solve for the y-intercept. So 2 to the power of negative 0. Negative 0 is just 0. So 2 to the power of 0, anything to the power of 0 is 1. So again, we've got a y-intercept of 1, and which means a coordinate that we can plot of 0, 1. If we want to let y equal 0, again, 2 to the power of negative x, and we'll rearrange it again, you'll see what happens. It's going to be the same thing as before. Log to the base of 2 of 0 is equal to negative x this time. The negative x doesn't make a difference. We're still taking the log of 0, which means there will not be a solution for this part. So again, try a different number to get another coordinate that we can join. I'm going to use x is equal to 2 again. So y is equal to 2 to the power of negative x. Instead of x, it's going to be 2. So that is 2 to the power of negative 2. And we can rewrite this as 1 over 2 squared. So if we take the reciprocal, if we flip it upside down, that negative power becomes a positive power. And it starts to look more familiar already. 1 over 2 squared is 1 over 4. Therefore, the coordinate we can put is x is equal to 2 and y is 1/4. There we go. So two coordinates, 0, 1 and 2/4. Let's plot the 0, 1 again. I'm going to put the 1 a little bit higher up. Actually, maybe not that high at the moment. Here. And that's going to be the first intercept we can connect. The second coordinate, 2, 1/4. I'll put the 2, x is equal to 2 there, and 1/4 is roughly here. So there'll be this coordinate and that coordinate. So the coordinates are in different positions from what we had last time. You can see that the shape was going in the opposite direction before. And this time it's on the other side. So if we were trying to connect these two coordinates with, again, with a curve, with an exponential curve, we're left with no real choice other than to do this type of shape. And that is, if I zoom out, that is the complete opposite direction. In fact, it's a reflection. It's a reflection in the y-axis. And that is because our variable has a negative in front of it. And that negative actually reflects it over the y-axis. This is an example of a transformation. There are many types of transformations that you can get in one exponential function, but that will be discussed a little bit later. At the moment, we really just wanted to sketch a exponential function, basic exponential function, looking at the basic shape and see if we can find any of these solutions, such as an x-intercept, which is not possible in these cases, and a y-intercept, of course. But anyway, I hope that is all, that you all understand that and it makes a bit more sense. That is the end of this video. Thank you very much for watching.